Start recording. Okay, so today we're going to continue where we left off last time. I think last time we finished on finding the length of a vector, and I'm not sure if we went over the numel function, but we're going to go over that today. I think we did, which is the number of elements in a vector. So we're going to go over that again because we went over that pretty fast last time. Okay, let's see. Let me share my screen. So if you weren't in the lecture just a few minutes ago, I'm going to assign homework today. It'll be not right after the lecture just because I'm going to edit the homework depending on how far we get today. But it'll be up sometime today, so just check Canvas, whenever later today. So I'll post the homework right here on today's page. So it says homework 1, intro to MATLAB, and that'll be posted again today. Or if you don't want to go to the today's page and you want to access the homework, you can just click on files on the left hand side and then click on the homework folder and it'll be posted in here. Okay, and then I'll put the due date on the homework as well. So I'm planning on having it be 1 week, but I'm going to think about that a little more. It's not going to take you an insane amount of time. In fact, you could really finish it in a day, I'm positive. But I want to give you some amount of time. Okay, so yeah, I just saw that question now in the chat for when it's going to be due. It'll be due probably next Wednesday, but again, I'll specify on the actual PDF for the homework. Okay, so any questions on the homework?
And the homework will be able to turn it in through Canvas, right?
Yeah. Mm-hmm.
Okay.
And then as for the lecture, I think I talked about this last time, but I continue to update this file here for the chapter 1 lecture. So for today, I just changed a few things in the lecture just to kind of update it for this semester. So if you want to download this new version, you can do that. Alright, so let's get started. So let's open up MATLAB if you haven't already. And first off, we're going to do a little review on what we went over last time. So last time, the main things that we went over were trig functions, making row vectors and column vectors, doing math operations on these vectors, and then at the very end, we went over how to make an evenly spaced array. So for our case, that was making an evenly spaced row vector. And then we also went over the length and the numel function, but we're going to go over that again in detail today. So let me move my video. Okay. So for trig functions, remember we can just put in the trig function that we want to use in MATLAB. So like sine, and then we need to put in whatever the argument is in parentheses. So like sine of x. Of course, I haven't defined x yet, so MATLAB wouldn't know what to do. So if I did before I started this lecture. So let's clear that. So if I put in sine of x and I didn't define x yet, MATLAB will say, this is an unrecognized function or variable x because nothing was defined for x yet. So if I do x equals 2, and remember I put in this semicolon here to suppress the output. It's still stored in MATLAB, remember that. It's in the workspace over here. But now if I do sine of x, then MATLAB will run that calculation to compute the sine of x, and by default, these trig functions are in radians. Okay, so that's pretty basic. Making a row vector and a column vector. So let's go over this because I think, maybe some of you forgot exactly how to go about this. So if we want to define a row vector, so just a collection of numbers on one row, we can do something like a equals, in brackets, 0. We can put a comma if we want, or we don't need to use a comma, but we have to put a space. So I'll do 0, 2, 3, 10. Okay, so this will be a row vector that we just defined. So if I press enter, then this is the row vector that we just made. So we have one row, and in this case we have 4 columns. So here's one row, and then 1, 2, 3, 4 columns. Okay, so again, if you want to use commas, if that looks more clear to you, you can do that, and you'll make the same row vector. And then we'll make a column vector now. So remember, to make a column vector, instead of commas, we have to put in a semicolon so we can go into a new row. So my first row, I'll put 10. So that'll be the first row in my column vector. If I want to go to the next row, I'll put in something like 2, and then 3. And then I'll close it out by putting in that right-hand bracket. And I'll press enter, and then we have our column vector here. Okay, any questions on making vectors? Okay. And then we could do math operations on vectors, so that'll be actually one of the exercises that I'm about to have you do. But remember, we could do math operations. So if we had like 2 row vectors, we could add them, we can subtract them. I think we only went over those 2, but we can multiply them and do some division. But that'll be something that we go over in chapter 2, because there are different operations technically for like multiplication. You can either do matrix multiplication, or you can do element by element multiplication. So that'll be a pretty big topic in chapter 2. So for now, we're only going to go over addition and subtraction for arrays. And so I might say an array, or I might say a vector, but a vector is a type of array. So an array in general, that's just more of a general term. It's just a collection of numbers. So an array can be a vector or it can be a matrix. Okay, so last thing here is going over evenly spaced arrays. So let's make a row vector that goes from, I don't know, let's do r equals, we'll do -20. And then so this is where the row vector here is going to start. So I'm going to start at a value of -20, and then my step size, so my interval for each number will be 5, and then I'll go to, I don't know, +20. Now if I press enter, then this is the row vector that we just made. So we started at -20, we had a step size of 5, so we're going from -20, we have a step size of +5, so we go to -15, and we keep doing that until we reach our final value of +20. So when we make a row vector this way, we don't need to have brackets. So you saw up here, I didn't have any brackets, but because I have this colon kind of notation, we don't need to use brackets. Okay. And also, we could make this a column vector as well straight away. But this is more something that we'll talk about again in chapter 2. But if I wanted to change this into a column vector, I would transpose it. So transposing, that kind of operation, that's when we flip all of the rows with all of the columns. So here we only had one row, so we put all of those rows into one column instead. So again, I just wanted to mention that now, but we're going to go over that in chapter 2.
Patrick, sorry I came in. Sorry if I came in a bit late. I had like a lot of people asking questions in my previous class. Sorry about that. Are you just reviewing?
Yeah, just review right now.
Wait,
Thank you.
Professor, how would I save the command window? Because I tried saving my command windows last lecture so I could use them for reference, but they just disappeared. I thought they'd stay. How do I keep them?
Yeah, that's one of the downsides of the command window. So we're actually going to go over how to make a script file later today. But if you wanted to save like everything that we already typed in today in the command window, we can't do that. So the only way that you could access those is it's still stored in your memory in MATLAB.
I could just like copy paste it onto like a Google Doc or something.
Yeah, but we're actually going to go over making a script file today. And that way, I would actually recommend using a script file. And again, we're going to go over it, but you can save that.
All right.
Okay, so there's a question in the chat. What does R prime represent? So I just wanted to briefly mention this. We're going to go over it in chapter 2 in more detail, but in this case, R prime, that stands, or the prime stands for the transpose operation. So that's something that you learn in linear algebra. And in this case, it took this row vector that we defined here, and it transposed it. So the transpose operation takes all of the rows and all of the columns, and it flips it with each other. So here we had one row, and we flipped it, so that row became one column. But we're going to go over this in chapter 2. Okay, so I'm going to clear this right now. And now we have an exercise for you guys. So you're going to create these two row vectors here. So create this row vector A, and then create this row vector B. And then you're going to add them. So you can make a new variable if you want, or you can just add them in the command window. But you could do something like C equals A plus B. Okay, so I'll give you a minute to work on this, and then we'll go over it. Okay, there's also a question, does the transpose operation work both ways? So yeah, if I had a column vector, I could then transpose that into a row vector too.
Hey, Professor, before I get started, for the B series, how would I write pi?
That's just pi.
You just type pi, right?
Oh, okay. Appreciate it.
Okay, so let's go over this now. And you're going to have one more exercise after this, so I'll give you more time on the next exercise. But this one's pretty simple, so all we have to do, first I'm going to clear my workspace over here. So remember to clear the workspace, we actually type out the word clear, press enter, and then I'm going to clear the command window, so that clears all of the text, so that's CLC. So first off, we want to create our row vector, so we can do A equals, it really just looks like exactly what I have on the slide here. So A equals 3, 0, -4, and 10. I'll put a semicolon to suppress the output. And I can either go on a new line now to make the row vector for B, or since I suppressed the output here, I can type in B. On the same line, I can type in B equals 1, 2, 10, and then for pi, all we have to do is type in pi. And MATLAB will be able to look at that and know that we want to have the character pi. Okay, so I'll press enter, and you can see in the workspace that we have our row vectors over there, and you see the value for pi, is correct. It's 3.1416, whatever. I never actually memorized pi like some people, memorizing 20, 100 numbers. I don't know. That's insane. So to add them, very simple. So we can either do A plus B, because I didn't tell you to make a new variable or not. But for this, I'll do C equals A plus B, and this is going to add these two row vectors. So if you just look at it here in the slide, you can already kind of imagine what the answer would be. We're going to have one new row vector that has 4 elements in it, so 4 numbers. And it should be, for the first value, 4, for the second value, 2, because we're doing 0 plus 2. The third value is -4 plus 10, so we should have positive 6. And the last value is 10 plus pi, so we're going to have 13.1416, whatever. So I'll press enter, and that's what we get. So if you're kind of a good way to think about this is we're adding element by element here. So I'm going to use that word, with, kind of like an emphasis on that, because that'll be something that's important in chapter 2, that terminology of element by element. So when we add these, we first do the first element for addition. So 3, that's the first element in this row vector A, and 1 is the first element in row vector B. So we add that, that's the first element for each row vector, and then we go into the second element for each row vector, so 0 plus 2, and then we keep going on like that.
What if the arrays have different size?
Yeah, so let's do that right now. So for addition, this will actually be okay, because let's say that for my row vector B that I have one more value. Let's put in, I don't know, 7. Let me put an enter, and then if I do C equals A plus B, this should work. Okay, it doesn't work. I thought it would actually. So I thought it would work because I thought MATLAB would basically just say that A has a value of 0 at the end, but I guess MATLAB actually does want you to have the same matrix dimensions as well. So, yeah, I guess I remembered that incorrectly. So they do need to have the same sizes, even for addition and subtraction. And then for same with matrix multiplication and division, they'll have to be the same size as well. Okay, so in this case, if I wanted to, like if I just gave you these vectors here, so 3, 0, -4, and 10, and then for B, if I had, let's say at the end here, add a value of 10, that would kind of be like almost a trick question or something to add these row vectors. So for you, in MATLAB, you would then have to put a 0 at the end of this row vector for A. Okay, so there is a question in the chat. How do we get less decimal places again? So to do that, use your format command. So you could do something like format short G. And if you use that format, you should have less decimal places. So if I type in pi, in this case, I have 4 decimal places, or 4 numbers after our decimal point. So I'll clear that. Okay, so let's go on to the next exercise here. So for this one, I want you to create these 2 column vectors. Make sure you make a column vector. They're going to be evenly spaced, and you're going to subtract them. So just as a note, when you make these, both of them will have a length of 10. And I said that because they just like we just saw, they have to be the same size when we subtract them. Alright, so you're going to make these and then subtract them. So if you need to go back in the slides that we have to refresh yourself on how to make these evenly spaced vectors, you can do that, but I'm going to stay on this slide right here. All right. Did everyone finish this?
You get all 12s.
You get 12?
Yeah, all 12s.
Oh, yeah. Okay, so let's go over how to do this. First off, I'm going to clear the workspace. We don't have to here, but I'm just going to clear it, and I'll clear the command window. So the first thing that we have to do is define our column vectors. and we're going to make them evenly spaced. So to do this, you can look at the slide here. I have it showing up. So I'm going to first define A. So to do that, I'll do A equals 2, 2, 20. I actually should have had you do row vectors, I guess. You could still define it this way, but I'm going to actually use the technique that I went over a bit earlier, which is when I transposed this. So we're going to have A equals 2. We're going to have a step size of 2, and then we're going to go to 20. And to make this a column vector, I'm going to use the transpose operation, which is an apostrophe. And then I'll press enter. So if I look into my workspace, you can already see from the semicolons that it's making a column vector. So if we double click on it, then we see that we have this column vector here.
Why column instead of comma?
I wanted you to make a column vector, so instead of a row vector. So to do that, basically when we first use something like this to have a step size of 2, and then we go to a final value of 20, if I have this right now, this will make a row vector. So if I press enter and I look at B, this is a row vector. But I want to make a column vector, so I use the transpose operation, which is an apostrophe. Okay, so I'm going to overwrite B now. I'm going to update B to actually be the correct column vector that I had you make in this exercise. So I'll do B equals, and we want to go from -10 to 8. So we go from -10, we have a step size of 2, and the last value is going to be 8. And then I'm going to make this a column vector by transposing it. Press enter. And also, you see when I transposed it this time, I actually wrapped this vector in brackets. So if we want to transpose it, we need to make sure that we're transposing the entire vector. So we have to wrap it in brackets. Okay, and then what we have to do is subtract them. So I'll do C equals A minus B. I'll press enter. And then all of our values here are a value of 12. Okay, so does that make sense to everyone?
Yeah.
Okay. All right. So we'll go over the length of a vector and the number of elements in a vector now. So we went over this last time, but again, I'm going to go over it in a little more detail today, just so we're clear on the differences between them. Okay, so let's first define a vector here. We'll do u equals, and we'll actually use the technique that we just learned. So let's do u equals 0. Let's have a step size of, I don't know, 1.5. And let's go to 100. Okay. So if you look in the workspace over here, we have our row vector u, and this is a size of 1 by 67. So this is already telling us that the size of this vector is 1 row and it has 67 columns. So to find the amount of elements in a vector, we can use two different functions. So we can use the length function if we want, or we can use the numel function, which we'll talk about in a second. So if I type in length of u and I press enter, then we get an answer of 67. So that's telling us that there are 67 elements or 67 numbers inside of this row vector. Okay, so that works. If we had a column vector, so let's do u equals u transpose. So basically this kind of formatting here, I'm updating the vector that we made up here for u. So I'm reassigning basically a new value to u. So we had u equals this row vector up here, and now I want to update that to be a column vector. So I'm going to do u equals u and then the transpose operation, which again is an apostrophe sign. So if I press enter, watch the size over here in the workspace. And now flip to be a 67 by 1 double. So now if I type in length of u, it'll be the same because we have 67 elements in this vector.
So if you had like a multi-dimensional thing, what would length output?
Yeah, that's a good question, and that's actually what we're going to go over, because it is maybe not unintuitive, but there is a specific kind of way that it calculates length then. So it's actually right here. So the length command, if we have a multi-dimensional array, it's going to give us the maximum, or it's going to give us the number of elements for the dimension that has the higher length. So let's make this bigger so we can kind of break it down a bit more. So right here, I have a 3x2 matrix. So I have 3 rows and 2 columns. So if I use the length command for this matrix, it's going to give us the amount of elements for the dimension that has the higher length, or the higher dimension. Or I shouldn't say that, but the higher length. So if we look at this matrix here, we have 3 rows and we have 2 columns. So if we type in length of A here for this matrix, it's going to give us an answer of 3 because we have 3 rows instead of 2 columns. Because 3 rows is higher than 2 columns, it's going to give us an answer of 3. So let's pretend that this matrix here had 5 rows and 2 columns. If we type in length of A for that, then we get an answer of 5. Okay, so let's actually go over this again in MATLAB to kind of see it again. So I'm going to make a matrix here. I'll make a different matrix than I have in the slide. So let's do A equals, and I also have a capital A here because again, the convention for a matrix is to use a capital letter. So I'll do A equals, we'll do 0, 2, 3, 4. So that's going to be our first row in this matrix. On a new row, we can do 1, 0, 2, 10, doesn't really matter. And this will be our matrix here. So I'm going to close it out with our right bracket. Then I'll press enter so we can see our matrix here. So if I type in the length of A, just in the chat, what do you guys think the answer would be in MATLAB? Okay, 4, 4, 4, 4. Okay. So yeah, it's 4. So in this case, it's looking, using the length command here, it's going to give us the amount of elements for whichever dimension is a higher number. So in this case, we have 2 rows and we have 4 columns. So the column kind of dimension for this matrix, there are more columns than there are rows. So the length command is going to work on the columns. So we have 4 columns here, so it gives 4.
How do you specify which one you want, though?
It does it just by the maximum, or whichever one has the highest dimension.
Unless you divide the amount of elements by...
Yeah, I don't think you can specify.
Alright.
Yeah, I'll look into that though. Okay, or if you just wanted to look at the size, like for either the rows or the columns, you can use the size function. We'll talk about that in a different chapter. And that'll just tell you right away that we have 2 rows and 4 columns. So you can do it that way too.
Does the row go first all the time?
Yeah. Okay, so if we wanted to actually still find the actual just number of elements in this matrix, and we don't really want to see how many elements we have for, some dimension. So like we just saw when we had our matrix A here, instead of, wanting to see, if we use the length function, we get a value of 4 because we have 4 columns. If we really want to find the number of elements inside of this matrix, so each number in here, if we wanted to find that, then we would use a different function called numel. So let me go to the next slide here. So numel, it's always going to calculate the number of elements in some array. So that can be a vector or it can be a matrix. So if I type in numel of A, it's going to give us an answer of 8 because we have 2 rows and we have 4 columns. So in this matrix, we have 8 numbers in here. So when would you want to use numel versus the length command? Well, it depends on what you want to do, of course. So if I wanted to just see all of the numbers in here, then I would use the numel command. If I want to see find the length or the amount of elements for the whichever dimension is higher, then I would use the length command. So remember, for the length command with this matrix, it gave us a value of 4 because we have 4 columns. And if you're looking at a vector, so let's make a vector here. I'll do v equals 0, 5, 10, 20. If I type in length of v and I type in numel of v, it's going to give me the same answer, right? Because the length of v, or the length function for a row vector, that's going to give us the amount of elements in that vector, so that's 4 in this case. And numel, it's always going to give us the amount of elements in whatever kind of array that we have, so either a vector or a matrix. So you can use either or in this case. The difference is very negligible in terms of speed. You're not going to notice any difference for what we're going to be doing in this class. So really the difference between the two functions here is more apparent once we use it on a matrix. Okay, so any questions on the differences between the two?
Actually, I actually have a question. So why put length and numel?
Yeah, so if you have a vector, you can use either or, and it's really up to you. I often use the length command just out of habit, but the differences really come in when you're looking at a matrix. So like here, if we use the length command on this matrix A that you see in this slide, MATLAB is going to look at each dimension, so it's going to look at the rows and the columns, and it's going to look at which of those dimensions has a higher number of elements. So in this case, the higher number of elements, or the higher number of elements for the dimensions is going to be 3, because we have 3 rows and we have 2 columns. So if I use the length command on this matrix, we're going to get an answer of 3. But if I want to have MATLAB tell me the amount of numbers that are inside of this matrix, then I will use the numel command, and that'll give an answer of 6. That makes sense?
I mean, like, I don't know, like, I get the definition. It's just, I feel like I should ask you, what does numel do?
Yeah, numel, no matter the array, so if it's a vector or a matrix, it's always going to give you the amount of elements in that array. So it'll give you every single number that's in there. It's going to count how many numbers are in that array.
Same thing with, what does length do then?
Okay, let's do another example, and maybe it'll clear it up a bit more.
All right, sorry, it's just coding. Coding's not my specialty in this area, so like I do have some trouble.
Yeah, you're fine. Yeah, it's a little weird at first looking at these two functions because they are similar. So let's make a matrix here. So I'll do 10, negative 20. That's going to be the first row that we have. Then I'll do, I don't know, 2 and 13. The numbers don't matter. I'm just going to make sure if you're following along that you make a matrix of the same size. So we'll do 20 and, I don't know, negative 30. Okay, I'm going to press enter. So right here we have a matrix that has 3 rows and it has 2 columns. So if I want to count how many elements are in this matrix, we know if we look at this right now, there's 6 values in here. There's 1, 2, 3, 4, 5, 6. So if I want MATLAB to tell me that, that's when I would use the numel function. So numel stands for number of elements. So if I do numel of A, then our answer is 6. So does that part make sense?
Yeah, it actually does. Okay, I see. All right.
Okay. So then after that, the length command is going to be different for this matrix. So the length command, if I use it on this matrix, it's going to look at the amount of rows that I have, and it's going to look at the amount of columns that I have. So we have 1, 2, 3 rows for this matrix A, and we have 2 columns. So the length command, in this case, it's going to either tell me the amount of rows that I have or the amount of columns that I have. It'll tell me, it'll give me an answer for whichever one is greater. So if I have more rows in this matrix, it'll tell me how many rows that I have. If I have more columns in this matrix, it'll tell me how many columns that I have. So we have 3 rows and 2 columns. Because 3 is greater than 2, MATLAB is going to give me the amount of rows that we have for this matrix. So if I type in length of A, it'll give me an answer of 3 because we have 3 rows.
Okay, I see. What happens? So okay, I see. So can you say numel plus length?
Yeah, if you wanted to. So yeah, in this
Okay, I
case,
see.
that would just be 9, of course. So we'll do it though. Numel plus length
You have
of
to
A.
be specific when it comes to saying numel or length. Okay.
Yeah. Yeah, it needs to take in an argument in the parentheses.
Okay, I see. Cause I feel like coding, like you gotta know the meaning of the the action you're putting. Like you said, numel is the total and length is the column total of the column and a row total of the row and stuff.
Yeah. Length, if you're doing it on a matrix, it's going to look at the amount of rows that you have and the amount of columns that you have. And whichever is greater, it's going to give you that number of rows or columns.
Okay, I see. All right.
Okay. Any other questions? Okay. So another way that we can make evenly spaced arrays is using a different function. So remember before we could make an evenly spaced array, not even with exactly a function, more of a command. So I could make an evenly spaced array from 0 to 10 with a step size of 2 by doing a equals 0, colon 2, colon 10. If I press enter, then you see we made this vector that has an even spacing of 2, and it goes from 0 to 10. So we can use a different function this time to make an evenly spaced array. So if we know the start point and we know the end point, and we know the number of elements that we want, so the length or the number of elements, but we don't know the step size, we can use a different function. So here, we knew the step size was going to be 2, so we could make this row vector just like we did up here. But if we don't know the step size, we can use a different function. So let's first find the length of A here, that's 6. And remember, I could have done numel of A, that would also be 6, because I'm doing it on a vector. Let's clear this. I'm going to bring up A again. So if I want to define this in a different way, so remember, basically imagine that I know my start point, which is 0, and I know my end point, which is 10. And I know the length that I want to have for this vector. In this case, it's 6. But I didn't know the step size, then I would use a different command. So this is going to be the linspace command. So here, just as an example, I'm going to make this exact same vector that we have up here, but with the linspace command. So if I type in linspace and put in a left parentheses, MATLAB will show up with this dialog box to show us the arguments that we can have. So there are different ways that we can construct a vector with this command, and you can see the different arguments here. So if we click on more help, the documentation will come up. And what we're going to use, we're going to focus on these 2 different syntax options up top here. So first off, I know my starting point, that's going to be 0. And I know my endpoint, that's going to be 10. And now for the linspace command, I have to specify the number of elements that I want in this vector. So in this case, if I want to make this exact same vector up here, I know that's going to be 6. There are 6 elements in that vector. So I'll do that, I'll press enter, and then we have the exact same vector. So, I made the same vector here, but just to show you how it works. But basically, we use the linspace command when we know our start point and our end point. and how many elements we want in that vector, but we don't know ahead of time what the step size is going to be. So if I make a new vector here like r, we'll do r equals length space, we'll do -13. So we're going to start at -13 and go to 256. And I want it to have, I don't know, 73 elements in that vector. Unless we do the math, which, you know, why do the math when you can just have MATLAB do this for you? I don't know the step size ahead of time. So here, I want to start from -13 and go to a maximum value of 256. And I want to have 73 numbers inside of this vector. So I don't know the step size right now off the top of my head, and you probably don't either unless you do the math. So if I want to make this vector, I'm going to use the linspace command instead. Okay, so let's press enter. And then you see in the workspace, our vector was generated. So it's a 1×73 double. So we have one row and 73 columns. And that matches up with the length or the number of elements that we specified up here, which was 73. So let's open up this vector and see what it looks like. So here's what it looks like. So we start at -13, and then we go to -9.2639. And then we go all the way up to 256. Okay, so does that part make sense?
Wait, how did it looks like the same syntax as the other one? How does it know the difference?
Because we're using the linspace command. For the other way that we made the vectors was
no, you also used linspace last time, but it looked similar when you're trying to. You didn't know how many elements you wanted or something.
Yeah. Okay. So last time I was just showing you that we can make a vector, you know, either like this, which is what we learned before, and I also used the linspace command for this as well, just to show you that we could use the same function to make the same vector. So here, when I use the linspace command here to make this vector, I have the start point, which is 0, I have the end point, which is 10, and then I specify the number of elements, which is 6. So, you know, this is a really simple vector that I made here. So I knew the amount of elements that I needed.
Up there, you have -13 would be the start point. 256 would be the increment, no?
No, 256 is the end point.
And 73 is?
That's the number of elements.
Oh, okay, I see. Never mind. It solves the increment for you.
Yeah, exactly. Yeah, so let's we'll go over this again. Let me clear this.
Patrick, wait, what did one of the students ask you again?
Basically just a syntax question. So I'm gonna re-explain it now.
Is it the line space they ask you?
Yeah.
Okay.
Okay, so let's make a new vector here. So first off, the linspace function, when we want to use it, is when we know the start point and we know the end point for a vector, but we don't know the interval or the step size. So that same thing. We don't know the step size for this vector. So let's make a vector u. Let's start at -22. Okay, so that's the first value for our vector. I need to put in linspace. So u equals linspace. The first argument is the first value that we want, so -22. The second argument, and you can see this right here in our dialog box, we're doing this line right here. We're going to put our second value, or the end point rather, that we want to have. So let's do, I don't know, 76. And then the last argument is n. That's the number of elements that we want in this vector. So maybe we want 123 elements in this vector. Okay, so what I should expect on the right hand side in the workspace to show up, I should expect to see a 1×123 double. So that is the size. That means we'll have one row and 123 columns, which means that we have 123 values in that vector, because we specified that directly in this function here. Does that part make sense to everyone before we continue?
So line space is when you.
it's when you know the first value that you want. So in this case, it's negative 22.
Okay.
And you know the last value that we want. In this case, it's 76. And you also know the length that you want, or the number of elements. So in this case, it's 123. But you don't know the step size ahead of time.
Oh, wait, 22. So for example, negative 22 is the line space, is that right?
Yeah, lint space.
Line space, and said, for example, 76 is what?
That's the last value. So let's look at this right now.
Right.
So we have lint space, negative 22. If we look right here, so I just opened up this vector. You see that negative 22, that's the first value. So we have negative 22, first value. And now we're just confirming that. So that's the first value that we have in our vector. And 76, that's going to be the last value that we have in our vector. So let's confirm that. I'm going to go to the very end of this vector. All right, there it is. Oh, went away. So that's the last value that we have, 76. And then the third argument that we had was 123. So that stands for the number of elements that we have in this vector, or how many numbers that we have in it. And you see that it says 1 by 123. So that means that we have 123 columns in this row vector. Is that a little more clear now?
I mean, like, do some example. I don't think it's kind of clear in terms of like.
Are other people unclear?
No, I get it.
Okay, so if you guys are stuck on it, just for sake of time, we can go over it again after class. But I don't want to spend too much time.
Go ahead. Sorry about this. Sorry about this. Sorry about this. It's just, I feel like it's Zoom, so it's kind of hard to focus. But sorry. Yeah, go ahead. Sorry about that.
Yeah, you're fine. Yeah, just stick around after class, and we'll go over it again. Okay. So we actually went over these syntax options. We didn't go over one of them actually. So we can also use lint space just with two arguments, and that'll be the first value that we want for the vector, and then the last value that we want. So let's make another vector here. A equals lint space. So my first value that I want for this vector, let's say 22. And then the last value, let's say 156. So if we only put those for our arguments here, again, 22, that'll be the first value, and 156, that'll be the last value. So if this is all we put for the linspace function, then MATLAB, by default, will assign a length of 100. So this will always give us a length of 100 if we only have two arguments for this function. So if I look at this vector, we start at 22, and we go to 156. There we go. Go back. Here we go. And again, by default, if we only have two arguments for the linspace function, MATLAB will assign a length of 100 every time. Okay. Okay, so finding a value at a specific location. So this will be something that we want to do, fairly often. So let's say that I want to find the value in this vector that we just made. If I want to find the value for the 88th element. So to do that, we could open up the workspace here. So I could double click on A. And I could go to the 88th kind of index in this vector. So I could scroll. And I could go to 88. Okay, here we go. And I could see that that's a value of 139.7576. So I could do that, but imagine that we have a vector that has like thousands of lines. So maybe it had a length of like 22,000, right? It would be very tedious to open up the workspace and then try to find, the 3,576 value. So that would be tedious. So instead we can use a function to just find that value. So for this example, let's say that I want to find the value for the 88th column in this case. I'm going to go over here. So we know just opening up the workspace that the value is 139.7576. But what I can do instead in the command window, let's I'll just do it this way. So to find that value, I'm going to put in A. So that's the vector that we just created. And if I want to find the value for that 88th element, I'm going to type in 88. And then I'll close out the parentheses, press enter. And then we get our answer here. So here, it says 139.76 just because of our format option. So let's do format short, and I think this will be, yep, that's now 4 digits. And we see that it's the exact same as we saw in the workspace.
Oh, okay, I see. So that's how you do it. So that's what linespace does.
Yeah, well, in this case, linspace started
all
from
right.
22 to 156.
Oh, okay, I see. Cause you brought that chart to prove that it is 130, to prove that it is 139.7576.
Yeah.
Okay, I see.
So if I want to find the value for the, the 34th element, I'll just type in A and then 34. So this will give us the value for that 34th element. Let's confirm. So I'm going to go over to 34. So we have 66.6667. I got a lot of sixes there. And that's what we saw here as well. So 66.667.
Oh my gosh, it's so much easier to understand than C. Oh my gosh, C++.
That's good.
I had a question. So for the linspace with only like with the two variables, it evenly marks it at 100, right?
Yeah, that's correct. Yeah.
And if you put a third one, which is like what could be like a random variable, like a number, and nth, right? It's gonna,
yeah. So if
gonna
I
compare that to that, right?
Yeah, if I had 3 arguments up here instead, the last argument is the length that we want to specify ourselves for the vector.
Okay, thank you.
So if we have 2 arguments, just like we have here, by default, MATLAB will give us a length of 100, which we see right here, 1 by 100. But if I wanted to have a length of, 200, then I would have to define this vector a little differently. So I could put, for the last argument, 200. So instead of being a 1 by 100 double, now it's going to be 1 by 200. So if I press enter, you see it updates to 1 by 200. All right. So we have another exercise here. So let's make this bigger. So I want you to generate a vector basically from 1 to 30 with 200 elements. So hint, you want to use the linspace command here. So we're going to start from 1, go to 30, and we want a length of 200. And then you're going to define a new variable called length, and use the length function as well to calculate the length of that vector that we just made. Or you could use the numel function. And then on another line, we're going to define a new variable called a to specify the value for the 57th element in that vector. Okay, so I'll give you guys a few minutes to work on this. Yeah, if you forgot to put the semicolon, it's gonna take up a lot of your command window. Yeah, if you have like, let's say you're generating a vector that has like, I don't know, 20,000 lines. If you did that, you know, it would keep going and going and going for who knows how long. So to terminate that, you could do Control C, just for future reference. Okay, so let's go over how to do this. Hopefully everyone's finished. If not, that's okay. So I'm gonna clear all of this. So the first thing that we want to do is create a vector. So I said domain, but you know, same kind of thing here. We want to make a vector that starts from 1, goes to 30, and it has 200 elements. So I'll just do, I don't know, d equals. So I'm going to use the linspace command here because I know my starting point, which is 1. I know my end point, which is 30, and I know the length that I want for this vector, which is 200. So I'll do linspace 1, 30, 200. And yeah, I put the semicolon. Let's actually, I'm going to press enter here. Okay, it did it too fast, but sometimes, if you have like a really large vector, it'll just keep going and going and going, and you can press Control C to kind of force terminate the script that's running. Okay, so there's our vector D. Now we want to define a variable called length, and for this variable, we're going to actually find what the length is for this vector. So I'll do length is equal to length of our variable, or our vector that we just made, which is D. And we see that the length is 200. So that makes sense because we explicitly defined ourselves that we wanted the length to be 200. Now I'm going to make a variable called A. And for this, I want to find the value for the 57th element in the vector that we made called D. So I'm going to put in D so we can reference that vector. Then in parentheses, I'll put 57. And that'll look at the 57th element in that vector. Press enter. And you see in the workspace over here that it says the value for that 57th element is 90.1608. So let's confirm that. Move this over here. Let's go to the 57th element. Here it is. That's 90.1608. And in our workspace, that's what we saw as well. So that worked out. Okay, any questions on that?
Where did you found your workspace? Or where do you go to your workspace again?
It should be on the right hand side here. It should say workspace. If it's not there, you can click on layout on your home tab and then click default. So layout and then go to default.
Default, okay. Layout. Okay.
Alright. Alright, next thing is polynomial. So we can make polynomials inside of MATLAB as well. So let's clear this first. So to make a polynomial, it's going to be in this kind of format of a row vector. Basically, we're defining a row vector to make a polynomial. So one note is our polynomial, it's always going to be created from the highest power to the lowest power. So on the slide here, if we want to make this polynomial, 3x to the third plus 5x squared plus 7x plus 2, we need to go from the highest power, which in this case is 3, to the lowest power to create this polynomial. Okay, so if we want to make this polynomial in the slide, we can define, any variable that we want. So I'll just say poly. And then we're going to just make a row vector. So in this case, we're going to put 3, which, well, first we'll make the row vector. So we have 3, 5, 7, and 2. We'll press enter. And what this really signifies is 3x cubed plus 5x squared plus 7x plus 2. So this last value is always just going to be some scalar. It's just going to be some individual number. Okay, and with this, we can find the roots of a polynomial. So I guess a little math review. The roots of a polynomial, they're going to be the values of x when our function f of x is equal to 0. So, if we have like sine wave, the roots are going to be once we go through the horizontal axis, so that value is going to be 0 for f of x. But that's math stuff.
Imaginary numbers.
What was that? Oh, yeah, imaginary numbers. Yeah, I mean, in this case, I had imaginary numbers, but, that was just for this example. If I chose a better polynomial, then we want to get imaginary numbers.
What if you had like a more complex function, like you wanted to add like a natural log to the polynomial? And you wanted to find the roots?
Yeah, so if I wanted a polynomial with the natural log, I could just put in log of 2, and that would just be part of it.
Actually, with this, I'm curious. So with this, does mathematician creates a complex poly structure?
Well, yeah, in this case, when I found the roots, it did have complex numbers, but, it just depends on the polynomial that you create.
So with this, I'm like curious. So with this, can you create with this? Do engineers create complex number to get the answer they're looking for? Because I know that with human there's a bunch of errors and stuff.
I don't really get your question.
So my question is like, like as an engineer, they with MATLAB, and they want to get like polynomial answer. With this, can they with this, if they type in like, for example, log into A, will they give you like a complex number that you're looking for?
Yeah, I mean, if it should be complex, it'll give you that. It just depends on whatever the polynomial is.
What if you wanted to add a term with like a negative exponent, like say x to the negative 2?
If you wanted to add it to the polynomial?
Yeah, and find the roots.
Yeah, you could put that in too, of course, yeah.
How would you do that?
For an exponent, it's just like, you could just do 2 to the negative.
No, I mean inside the polynomial. So say you have like x to the third plus x to the negative 2, and you wanted to find the roots.
Okay, yeah. So if we had the okay, let's do it like this. So if we have basically 3x to the third plus 5x squared, let's say, and then you wanted 2x to the negative 2, is that what you said?
Yeah, something like that.
Then yeah, actually, yeah, let me think about it. To the negative 2. Oh, I think in that case, we would just have to keep going down. So, here we terminated at a value where it was 3. Actually, no, because if we continued,
it's gonna increase the exponent in the front, right?
Yeah, I would actually have to look that up.
Right.
That's a good question. Okay. I'm going to write that down so I don't forget.
Wait, so why did he ask that? I'm just curious because like I wasn't listening while I was like copying yours.
Yeah, so he had a question if we had a polynomial that had a negative exponent. So let's go back a slide here. So for this polynomial that we have here, all of our exponents are positive. We have, 2x to the fourth, we have x cubed, x squared, and then we have x. So in MATLAB, at least by default, the nature is when we define a polynomial, we're always going to have a positive exponent. So we have 4, 3, 2, and basically 1 here, and then 0. So yeah, he was asking, what if we really have a negative exponent? How would we define that in MATLAB? And off the top of my head, I actually really don't know, so I'll have to look that up.
Wait, can you put negative exponents or no?
You should be able to.
You shouldn't, or should you?
You should be able to.
Okay.
Okay.
Interesting, actually. Very interesting.
So if we want to find the roots of a polynomial, then, really easy function here, we just use the roots function. So if I want to find the roots for this polynomial that we defined up here, which is 3x cubed plus 5x squared plus 7x plus 2, we're just going to use the roots function. So I'll do roots of poly.
Can you find
in this
schema
case,
with
what was that?
MATLAB?
What was the question?
Can you find like minimum and maximum?
Yeah, we'll do that in chapter 2.
Oh, okay.
Okay, so if we use the roots function for this polynomial, it'll give us the roots. So in this case, we have complex numbers, but of course, depending on the polynomial that we define, we might not have complex numbers. Okay. So a more efficient way to write this code, so in this case, I have 2 lines of code here to find the roots. I could have just done roots and then define some polynomial. So let's say, I don't know, 2x squared plus 3x plus 5. And that'll give us the roots for this polynomial. So we can do that on, one line. But a lot of times in MATLAB, we actually want to define our polynomial as a variable first in case we want to reference it later on. So in that case, we would just use the way we did it up top here. Okay, so files. So we already know the workspace over here. We've been kind of referencing the workspace throughout. And I think last class someone had a question on how to save the workspace. So
that was today.
Really, that was today?
Yeah, I just asked in the beginning.
Okay, I think someone had a question in the last class too about how to save the workspace. I think you were asking how to save the command window, right?
Yeah.
Yeah, that's different than the workspace over here.
Oh. Okay.
Yeah, so the command window is where
I managed to save the workspace, just not the command window.
Okay. Yeah, so yeah, we can save the workspace over here, which stores all of our variables. So you can do that up top here. There's save workspace. So you can do that. And you will see that the file type is .mat. So that's the file type for the workspace. Or you can go in the command window here. And if I want to save this workspace, I can type save and then whatever I want to call that file. So let's call it workspace example. Okay, I'll press enter. And then you see on the left-hand side in my current directory, that file shows up. So it's a .mat file. Once again, that's for the workspace. And then if I wanted to import this, I could just go to import data and I can just double click on this and it would open up. So let's actually show this right now. Okay, so I cleared everything, so there's nothing in my workspace. If I want to import that workspace that I just saved, I can go to import data and then I can double click on this or just click open. Okay, so it's going to give us a little wizard here to import the workspace. So let's say that we want to import all of these. So I'm going to leave it by default where they are all checked. And then I'll click on finish. And now our workspace is imported. So to be honest, I don't do this very often because I typically use a script file instead. So if you save a script, which we'll go over in a second here, you can save your script file, and then in that script you will have lines of code where you define a variable, so your workspace is always going to be generated when you run that script.
Patrick, I have a question. Can you save your coding too?
Yeah, so right now in the command window, we can't save everything that we typed in here. But if we want to save it all, we would use a script file. So I'm going to talk about that right now. Okay, so to save, everything that we typed today, as we currently have been using MATLAB, we can't save it because it was in our command window, which is typically used just for finding, the value of some element in a vector or something like that. It's not for basically long-term use. So, typically when we're in MATLAB, we're actually writing a program. And when we're doing that, we have a script file. So to make a script file, we're going to go up top in the top left here and click on New Script. Okay, so if you click on that, you're going to see that this new window pops up, which is the editor window. And we still have our command window down here, at least by default. You can rearrange everything if you want, but by default, the editor window to write a script should be up top. and the command window should be below. So I'm going to go in the command window, I'm going to clear the workspace. So I type in clear. And probably from now on, starting next class actually, we're going to use script files all the time because I think they are more useful even for you as a student, so you can save that script file and kind of go back to what you were working on before. So if we have a script file here, and again, I know I say this a lot, but we're going to go over this in more depth later on. But let's start out a script file with a comment. That's typically what we do. So, for you guys in class, you might want to start out with a comment of the date. What's the date? The 3rd? Yeah. So I'll do 0203, chapter 1, intro to MATLAB. Okay, so that's a comment just so I know what the script file is going to go over. And then we will often have a script file with these clear functions or clear commands. So clear, remember that clears the workspace, and then CLC, that'll clear everything in our command window. So once we talk about script files in more depth on a future class, I'll talk about in more depth why we always want to have these commands up top here. Okay, and then below this, we start writing whatever our script is. So, for you, once we're in the class, we'll be going over all of the examples as we have been doing lately. And then you can basically start them out with a comment, or you can make a section. So I think we discussed this before. So to make a section, we use 2% signs. And then you see that this kind of yellow box pops up. So I'll do like example 1. We're actually going to discuss linear algebra right now. So I'll put in linear algebra. And then we're going to have, for now, I'll just put a comment. So here's our problem. Okay, and then let's imagine that we finish this exercise and we're on a new one. So I'll use 2% signs again, and this will be like example 2. I don't know, something else. So you see that in each of these sections, they're kind of sectioned off with this kind of background color. So this is just a good way to organize your script file. Okay, so now, oh yeah, I should also go over how to save it. So if you want to save your script, we're just going to go up top here and click on Save. Click on Save As. And here is our script. So let's just say, I don't know. I'm going to call this example script. You'll see that I used an underscore. So when I save a file in MATLAB, you can't have any spaces in your file name. So if I did example script, if I save this, we'd get an error, at least if we tried to import it. Yeah, okay, it already gives us an error. So you see here, I couldn't save this file name because our name, it has to start with a letter, and it can only contain letters, numbers, or underscores. So we can't have any spaces in there. So I'm going to put an underscore, and I'll save that. So imagine that you saved your script and you want to look at it later on. All you have to do is double click on that script and it'll open up for you.
Oh, wait, so with the script, you could just, with the script, like let's say you've been working MATLAB for so long, but yet your work is not due. You could just copy your code, create a new script, then paste it there, then after that save it, and if you want to come back to it, you could just copy and paste it there.
Yeah, if you want to go back to it and you saved your script file, you just have to double click on it and it'll open up.
And from there you could just copy and paste it to the command window, right?
You could, but it wouldn't really make sense to do that. You would actually just want to stay inside of this script folder, because we can actually run this. I'll show you an example. So let's make a vector here, 222, sure. So we don't need to use the command window. In fact, from here on out, we're not going to use it too often anymore. So we're actually just going to be using this script window right here. So I can run this right now. So I can press run up top here, or I can press F5 on the keyboard just to save some time, and that runs it as well. So you see it showed up in my workspace over here for that vector I just created. And then I could go in the command window and I can type in A if I wanted to see that output for that vector.
Oh, okay, I see.
Yeah.
I see. I mean, it's obvious that you should create a work file that you're gonna work on, right? Or you're gonna save it, right?
Yeah, you should always save your script. So you don't need to save the workspace though. I know we're out of time here, so if you guys have to go, you can leave now, but I'm gonna go over this part. Okay. So here I saved my script. So let's close out of everything. I'm gonna clear everything here. So you see there's nothing in the workspace anymore. And let's close out of the script file. So let's say that we saved this and I want to go back to it next class, right? So I'll open up the script file by double clicking it. And there's nothing in the workspace right now, and I didn't save that workspace. But if I run my script, then this variable comes back in my workspace because I just ran the script and I created this row vector A.
Okay, I see. Okay, I see. So each time you do new code, do you wanna create a new script? You wanna create a new script and save it, right?
Yeah. Sorry, my clipped. Typically, yeah, that's the case.
Okay, all right. Makes sense.
Yeah. So I didn't go over this in the very beginning of class just because I want to go over basic arithmetic and functions in the command window. But from here on out, especially once we start chapter 2, or actually once we get to plotting, we're gonna use the script window most of the time.
Someone asked, when will the homework be uploaded?
Yeah, it'll be uploaded sometime today. I'm gonna modify the homework now to only have everything that we went over in class.
All right. Hey Patrick. So for the homework, if we need help, would you be helping us in Discord too?
Yeah, I would recommend asking the question in Discord. Yeah.
Okay. I mean, it's good that you create a Discord, even though like your job is as a professor.
Yeah, I think a lot of instructors are using Discord more often now, too. Okay,
Thank
so
you,
there's.
Professor.
Yeah, I'll see you guys next
I have
week.
one question. Sorry.
Okay, I'm gonna answer someone that they had a question a few minutes ago, just to get them first. So there's a question that when they put 2% signs, they had a dark brown box. So to change that, you can go to the Home tab, click on Preferences, and then you're gonna go to Colors, and then under Colors, click on Programming Tools, and then you'll see Highlight Sections, and you're gonna change that to, or you can just click on Restore Defaults. Or if you want a different color for that background, you can do like, this will look terrible, but you see now it changed to a pink. Okay, so that was Preferences, Colors, Programming Tools.
Perfect, thank you.
Okay, there's another question on, can this program work for integrals? I'm pretty sure MATLAB does have a function to calculate integrals. I've never used it myself, but I think they do. But because it's programming, I'm guessing that it's an approximation, not an exact solution. So kind of like Riemann sums, if you remember that from like Calc 1. So it's going to be an approximation.
Patrick, may I ask you something? What system are you using, Mac or Windows?
Oh, for this computer that I'm currently showing my screen on, I'm actually using Linux.
Linux? Okay, because it looks different when you saved it. Because I'm using Windows, it didn't look similar.
When you save your script?
Oh, well, your script. Yeah, your script. Yeah.
When you save the script, it should look, very similar to what I had here, even if I'm on a different operating system.
Yeah, it looks. Yeah. It's same, but. Okay, I see. What's the workspace example you did again?
Oh, here?
Yeah.
On the left? I saved the workspace. So that was earlier on. Typically, I don't save the workspace because we're usually using a script file, which will generate stuff in the workspace for us.
I see. Wait, so how do you look at the Excel thing that's similar. I don't know what do you call it.
Yeah, I think you're talking about this, right?
Yeah. How do you go there again?
You just need to double click on your workspace on a variable in there.
Oh, okay, alright.
Or you can go in that command window and you can actually type in workspace and you press enter. It should open up. Why didn't it open up?
Hey, Professor, I have a quick question.
Uh-huh.
So for the homework, are we gonna need to upload anything to like Canvas in regards to like saving a script?
Yeah, so I'll give you instructions on Canvas on that page, but most likely, at least my current plan, and again I'll specify, but I'll have you basically copy and paste your script, and you'll paste it inside of a text box on Canvas.
Oh, okay. Okay. So that's instead of uploading the actual script.
Yeah.
As a file. Okay. All right. Thank you. Have a good one.
You too.
Oh yeah, Patrick, I got an email saying that they're offering a tutor for MATLAB 2, free tutoring.
Oh, okay. That's good. Yeah, it's not me, it's someone else, but that's good.
And yeah, so if people need help, they could go there. They should check their email. They should get an email saying you could get a free virtual tutoring.
Yeah, that's good. Okay, there's a question. So, what computer would I recommend for engineering majors? Probably a PC, to be honest, because like on a Mac you don't have SolidWorks. You can't install that on Mac OS. You could, like if you have a Mac and that's all you have, you could actually install Windows on your Mac too and run it that way. But most programs, they're on Windows for sure, but not all of them are on Mac. So I'd recommend Windows, some kind of PC. Oh yeah, I used Boot Camp. I did that before too, and it still works fine, but it doesn't work as well even through Boot Camp, from what I saw. But I mean, other than that, the programs we used, at least for undergrad, they're not too intensive, so you don't need like some hardcore PC. Yeah, you too. Alright, does anyone else have any other questions?
Actually, go ahead.
Professor, so when you input something into the script file, should it automatically show up on the workspace? Or do you have to click run in order for it to go through?
Yeah, you have to click run.
Oh, okay.
Yeah, so yeah, you can either go up top or click F5.
Okay, thank you.
Yeah, Patrick, so you said just for clarification again, with the script, if we write our code and if we click run, the answer should pop up in the workspace, right?
Yeah, so let me clear it right now.
Okay.
So you'll see once I press run, it will show up there. So press run and then it shows up.
Okay. So you press run. Okay. What's a run in advance?
That's mostly for debugging. So it'll basically run each section that we have, or it might even do it line by line. No, it goes to the next section. Let me show you this really quick. So we have example 2. So if I'm in this section here, remember we make a section by using 2% signs. If I click run in advance, then it goes to the next section. Let's do it like this. Example 3. So if I'm here and I press run in advance, it'll go to this next section. Then if I press it again, it'll go to the next one. So we would do this if we want to kind of debug section by section.
Oh, okay, I see. Cool. I see. If we want to work on if we want to work on new code, we should again create a new script, then put our code there and save it. Like for example, for another assignment that you assign us.
Yeah, so yeah, just make sure you save this one, and you could close out of it, and then just make a new script.
How do you save your workspace again? So do you just Do you go to workspace and? Oh, okay, I see.
Yeah, you can. Yeah, you can do it right there. But if you're using a script file, you shouldn't really ever need to save the workspace because if you run your script, it's gonna generate all the variables in the workspace.
Were you about to show us how to save our workspace, like how to save not workspace? Were you about to show us how to save our code? Because I was about to ask you that though.
Well, yeah, I showed you for a script, but you can't save the code from the command window.
Command window?
Yeah, that's what we've been using so far up to the very end of today.
But when you say save your command window, you're referring to the script, right?
No, not the script. So I'm in the command window right now. So that's what we've been using, in the past few lectures. And if I press up on the keyboard, this is everything that I've typed lately. So I can't save all of this stuff.
How do you go there?
You press up on your keyboard.
Shoot. Okay. You press up on your keyboard. Up. Oh, okay. I see. Does it save for you automatically even though you close your window?
Yeah. Yeah, this stuff is from, if I go way back up here, this is stuff from, geez, like 2 semesters ago or something.
Oh, okay, I see.
Yeah, there's quite a lot in here. I don't know how many lines it saves and then it starts to clear. I'm not sure, but there's a ton of stuff.
Oh, okay, I see. All right, cool. Okay, I see. For the homework, will we be submitting it through Canvas?
Yeah, so I'll give you instructions for that. I think I'll have you basically copy and paste all of the code you wrote, and then we'll copy and paste it inside of a text box on Canvas.
I see. You're like the most straightforward professor I ever worked with when it comes to code, because I actually did C C++. My professor wouldn't even explain what it means exactly. He just like I don't know. Whenever I ask him questions a lot, he just says I don't work hard hard enough.
Why would
I don't know.
that?
I mean, like he didn't say that, but he just says that like have you like been practicing a lot? Honestly, yes, I've been going to tutor a lot. I still didn't get what the coding meant. Like I still didn't get what the definition meant.
That seems pretty harsh of him.
He's not a professor exactly. He's just I don't know. He's just our instructor. But I don't know. Like the definition didn't really make sense to me when I did coding.
Yeah, I try to be as clear as I can, and it's good when you ask questions too, because I'm sure other people have the same question, but they're just not asking.
Yeah, I mean, people says not to ask too much question. I get that, but like I don't know, so I will ask.
Yeah, that's good. Yeah, you should always ask.
All right. I see. Anyway, thank you, Patrick. Actually, before I go, if people ask you for help in Discord, will you like help?
Yeah, I'm pretty active in there, so I'll help you guys out. I mean, like the first thing you guys should ask, other students to help out, but if all of you guys are stuck, then I'll hop in there and then I'll help you out.
All right. Thank you, Patrick. I'll see you next week on Wednesday. No, wait, not Wednesday. Monday.
Yeah, yeah. There is one Monday that we have off. I think that's the 15th, though.
Yeah, I thought next week was 15th. All right.
Okay. Yeah, I'll see you then.
All right. I'll see you Monday.
All right. See ya.